Hello everyone, in this short video I'm going to explain a non-repeat pattern in pneumatic circuits. A non-repeat pattern has this typical example for a non-repeat pattern in pneumatic circuit is A plus, B minus, then A minus, which means if you have two cylinders A and B, then A extends, then B extends, then B retracts, then A retracts. Normally using roller valves and the kind of automation that we do, this stops in the middle of the cycle and does not repeat on itself because of the way it is designed. So because of the way the piston heads and rollers are designed, as long as the piston head is on top of the roller valve keeps producing a signal that is sent to a power valve, and as a result of that, power valve sends another signal to the cylinder B and asks it to extend. And when you have fully extended the cylinder B, now you want to retract it, so you produce the signal and send it to the power valve, but it cannot really accept that signal because it already has a signal from the fact that the piston rod of cylinder A is still on top of this roller valve and continuously producing a signal. And that's why this is called the opposing signal, which is A1 in this example, and B1 cannot tell the power valve to retract the cylinder B. That's why it is a non-repeat pattern. However, I'm going to show you in this video how by using roller valves with hinge we can actually break this continuous signal into a pulse, and thus being able to have this pattern moving in a repeat cycle, even though it's a non-repeat pattern. So theoretically speaking, it is only possible when we can break this signal before we can send the signal to the power valve. This part have to be cut off from this roller valve, and the hinge roller can actually get that part down. So if we just switch to a hinge roller instead of a standard roller, then what happens on its extension from left to right, the piston head hits the roller and creates the signal A1, but that signal is not continuous. It's only a temporary signal, because after it hits it, it goes past that further to the right, and thus this roller simply trips and creates a pulse. So this continuous signal is changed into a pulse, and that way we don't have any more blocked signal here. Now once B completes its own extension, it will also create a signal, and if we feed this signal back to the same power valve asking it to retract the cylinder, it is now possible because there is no opposing signal in this part. Now I can show you this thing in the automation studio, that way it becomes even more real. So let's see this in automation, and here I built the entire circuit using two cylinders. One is horizontal, this is our cylinder A. One is vertical, this is the cylinder B. And look carefully that I have used 1, 2, 3, 4 roller valves, and two of these 4 roller valves are hinged roller. So what I'm trying to do here is I'm going to use the extension motion of this cylinder rod A. On its way from left to right, it will hit the roller valve, trip it, and then we'll send the signal to the power valve, and the power valve will trip, and then it will send the signal to the cylinder B and it will extend. Once the piston rod comes out all the way, it will hit this roller valve here and trip it, and then the signal will be passed on to the same power valve and asking the same cylinder to retract, and then it will retract. And on its way back to the cylinder, this piston rod will hit this hinge roller. Look carefully that when it's going up, it hits the roller, but it doesn't create a signal because the way it is broken on this in that way. So it touches this roller on its way up, but it doesn't create a signal. It only creates signal on its way down. So the piston, when it's returning back into the cylinder, it will produce a signal and trip this valve, and that signal can be passed over to this power valve to retract this cylinder. Okay, and also when this piston is retracting back into the cylinder, it will not produce a signal even though it will touch this roller, because it's broken from right to left. Okay, so let's watch it, and I'm gonna have to trip this toggle to go to semi-automatic to full automatic. But before I do that, I'm gonna pick slow motion animation because it's gonna be too fast otherwise to observe. Now I'm gonna trip that, see it extending. Now this one is extending. Now this one is retracting, and then this one is retracting. So we are actually making sure that even though it's a non-repeat pattern, A plus, B plus, B minus, A minus, there's a trapped signal, or at least supposed to be a trapped signal, but using the hinge roller we broke that. So we are still making it sure that even though it's a non-repeat pattern, it can still run on itself without me doing anything. So after clicking that button, I'm actually not using my mouse to control any motion. I'm just showing you around, but see that the two cylinders are automatically running following the sequence. So from now on, let's follow the extension of A, extension of B, now retraction of B, followed by retraction of A. And this way the cycle keeps on going, and using the two hinge rollers made it possible to work around that trapped signal. There is no more trapped signal in this one. There is no continuous signal by the extension or the retraction of the cylinder A and B respectively. That way we can make a non-repeat pattern, change a non-repeat pattern into a repeat sequence by using hinged rollers. Hopefully this was helpful. Hope you understand that, and thanks for watching.